Benjamin Cabe. I work at the Eclipse Foundation. I might be a bit out of breath right now. The thing is, I have what I think is a cool Internet of Things demo. I just forgot it in my hotel room. So much for working late on the demo yesterday and just being so confused this morning. So yes, I do work at the Eclipse Foundation. We are about 20 people working there. And I just want to make it clear that Eclipse is really not just about the Eclipse IDE, the Eclipse Java IDE. Just like Apache, and the Apache Foundation is just not about the Apache HTTPD server anymore. So we actually do a lot around the Internet of Things, and I want to talk today about what we have, what open source projects we have to help you build IoT solutions. And of course, since the IoT is, well, sure, a buzzword, but also quite a new domain, I want to also make sure that you guys understand what are the challenges and where open source can help you solve some of those challenges. So I will try not to bore you with too much details about the how many billion devices are going to be connected to the internet by 2020, 2025, whatever, but I just want to make it clear that IoT is not only a buzzword, it's actually solving some interesting needs, and hopefully it's going to help us as the human race to become smarter and more green, more efficient, and more free maybe to do something else because, well, in terms of electricity production, for example, if you think about every household having a smart power meter, then the utilities, they can start producing electricity and optimize the production depending on the actual consumption in a specific area of the town, because as you probably know, it's kind of hard, if not impossible, to store electricity, so you really need to optimize the actual production, and this is where connecting your power meter, connecting all the electricity production plants can help optimize the production in general. Same for everything fleet management. If you start thinking about tracking the GPS location of all the FedEx or UPS trucks all over the world, then maybe you can start thinking about optimizing the route and the path that the trucks are going to use, depending on whether people are actually at home or not. Well, basically you check their Facebook status. I mean, that's the kind of stuff that could actually be improving our lives, right? And again, our efficiency, etc. Connected cars. A very, very simple use case, and which is actually also a not so intrusive one, I believe, is to have a little device in the car that is essentially a SIM card, a little microcontroller, and if you have an accident, then the car is able to text the emergency services automatically and text your position, basically. And many, many other use cases like this, healthcare, etc., etc. So yes, there's going to be billions of devices connected, and hopefully it's going to help some solve some actual needs. And what some people don't really think about and should think about is that to build these IoT solutions, and to Dayan's points yesterday about trying to do sort of a call to action to all of you guys to get involved, yes, there's going to be a need for lots of developers. In the next decade, we're going to need to have millions of developers aware of IoT. And what do developers like? I mean, I'm sure you guys like working with open and open source technologies. So this is where open source foundation like Eclipse hopefully can be a home for open source IoT. And that's exactly what we're trying to do with what we call Eclipse IoT. So we have this initiative going on for about 4 years now, and we're now a home for close to 20 open source projects that help you build IoT solutions. We provide frameworks, we provide implementations of protocols that help you connect your things, that help you make your things talk. And we don't think there's going to be just one language, just one approach for IoT. So our projects are actually, lots of them are in Java, but if you're an embedded developer, you will also find some cool libraries for doing MQTT, that kind of stuff. So that's what I'm going to talk about today. And as I said, I want to kind of do a quick intro to what a typical IoT solution usually is. So you have those sensors, your smart meters, your cars, etc., your temperature sensor or thermostats that you want to connect. So how do you connect them? Well, maybe some of them will have sort of built-in and direct internet/IP support, like they are able, right on the chip itself, there is a Wi-Fi module, there is a ZigBee stack, stuff like that. So maybe those things you will actually program them directly, or more likely, especially if you're connecting legacy solutions, legacy devices, you're going to use an approach where in order to connect those things that are probably able to be interacted with over a serial protocol or over some sort of existing legacy protocol, you're going to bridge them to the internet by means of a so-called gateway, an IoT gateway. And in the end, what you want to do is be able to take all the data that's coming from these devices and take that to the internet. So you're going to need to use some dedicated protocols probably. You want to have a solution that scales because there's going to be thousands of, if not millions, devices. And eventually, once you've been able to connect the devices, you will want to use the data, visualize the data, display, interact with the devices from your smartphone, consolidate the data into your Hadoop clusters, et cetera, et cetera. So that's kind of the end-to-end chain of IoT. It's super simplified, but that's kind of the typical high-level architecture. So you need to connect the things, you need to visualize the data, and actually, so what you need to do to connect, we're going to talk about that, but in between the sort of addressing the connecting part and the data analytics, data visualization part, you're going to need to think about how you're going to manage your solution on the field. When you start playing and tinkering with your Raspberry Pi, with your Arduino in your garage, that's pretty easy to interact with the device. If something goes wrong, you just unplug the device, it's going to reboot. If you have a fleet of devices on the field, then you need to actually do proper management of the solution, and there's several challenges here. So let's start with the connectivity part. In the realm of IoT, you have lots of constraints. You talk about very constrained devices, very small devices. In terms of connectivity, you're going to use probably some sort of wireless communication channel, like cellular, Wi-Fi, ZigBee, 6LoWPAN, that kind of stuff. The network is going to be constrained, not very reliable in that some of the endpoints are going to die because they don't have enough battery, and you're going to have range issues and stuff like that. So you need protocols that help you in that regard. The bandwidth is also probably costly one way or the other. Like if you use 3G to connect your devices, then you need to pay how many, whatever amount of euros, dollars per month, per megabyte, right? And the communication patterns are quite different to what you may see in other domains. Like you will want to do one-to-one, one-to-many communication. You will need to implement also some security policies, etc. So dedicated protocols are needed. And it turns out that there's lots of protocols for IoT, and they uncovered that yesterday. But two very popular protocols would be CoAP and MQTT. CoAP, if you remember yesterday's presentation, would sit more on the Web of Things side, in that it's essentially implementing the HTTP/REST model on top of UDP, whereas MQTT comes and sits on top of TCP and is essentially a pub/sub model dedicated and suited for the IoT and machine-to-machine constraints. So Web of Things, a quick recap, that's where I think everyone wants to be in a few years. We're not there just yet, but ideally, when the Internet of Things done right would look something like this, where all the devices all around you are essentially all little REST endpoints, and if from your smartphone you need to interact with a light bulb, then you use some sort of discovery techniques to discover the light bulbs around you, and you get the status of the /on resource, or you put a new payload, which would be true or false, I guess, on the /switch resource and stuff like that. So CoAP, if you want to play with CoAP, you should definitely first read the spec, the RFC, the IETF RFC. It's actually quite a nice read. And in terms of implementations at Eclipse, we have sort of the reference implementation in Java, which is called Californium, which implements all the CoAP stack, plus the DTLS part for securing your UDP communication channel. There's no DTLS support in Java per se, so that's kind of a nice addition. And it's very simple to deal with CoAP. In a nutshell, it's just like servlets in Java. You model your resources, similar to how you would model a servlet, and you mount your resources to your CoAP server. So a resource, and hopefully you can see that quite clearly. If I were to expose sort of a hello world resource, then I just need to implement my CoAP resource and make sure that I provide something to do whenever someone does a get, and I can also handle maybe the post, and depending on the content type of the post, maybe I will do some, and depending on the request options, I will react differently. But that's really pretty simple. And yeah, many people start using CoAP, especially in the field of wireless sensor networks, because, well, the footprint is just way smaller than other protocols based for example, on TCP. MQTT, I think you've heard about MQTT a couple times yesterday. Just to a quick recap on the principles, very simple. You have this central broker that's going to help you orchestrate all your endpoints, all your clients, and imagine you have this kettle that you want to monitor from your smartphone. Then what's going to happen is that the smartphone is going to be one MQTT client, this guy is going to be another MQTT client, and here I'm going to subscribe to a topic hierarchy, which is essentially anything under kettle 123 blah 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 / something is something that I, as a smartphone app, I'm interested in. And then later on, endpoints will possibly post data on a topic that matches my subscription, and then I will be notified and I will receive my payload. So that's very simple, and there's some nice features in MQTT, like well, the wildcards, of course, for doing the sort of the pattern matching and consuming several publishers from one subscriber, different quality of service levels, depending on how reliable you want your messaging and your delivery to be. Nice features for noticing when endpoints do die, and that's called the last will and testament. And you can also retain and persist messages on the broker. So that's, again, quite a nice read, the specification. It's an OSGi standard, actually. And at Eclipse, we have both the clients and the servers. Everything client would be Eclipse Paho. So go check out eclipse.org/Paho, and you will find Java client, JavaScript client, C, .NET, Go, Lua, etc., etc. Etienne, Lua, that's for you. And the API is pretty simple and would be similar in all the languages. You want to establish the connection to your broker. We actually host a sandbox at Eclipse, so you don't even have to deploy your own broker. You define your Java callback whenever there's going to be a message matching your subscription. You want to be notified and process the incoming message, and then you connect to the broker and you subscribe to whichever topic you're interested in, and that's it basically. And we're going to see that it's similar in other languages. On the server side, several brokers are available in open source. At Eclipse, we have Mosquito, which is like the most popular one. It's been around for, I think, about 10 years now. It's pretty scalable, pretty easy to customize. You have a plugin model if you want to plug your own authentication mechanisms and stuff like that. So it's in C, provides TLS support, WebSocket support, and stuff like that. And there's also several other implementations out there. For if you want to integrate MQTT support in your Java backend, Mocket might be a better option. If you're an Erlang kind of guy and you want to build a nice scalable cluster-based infrastructure, VernMQ is in Erlang, node implementations, etc., etc. And by the way, don't know if you guys, well, you are probably partying already yesterday, but at Amazon reInvent yesterday, AWS, Amazon just announced that AWS is going to support MQTT now. So if you want to build an IoT solution and sort of tie it into all the other AWS services, there's something for you at Amazon now as well, which is, I think, pretty cool and tells something about MQTT. It's now being very, very widely adopted. All right, so maybe you think that now we're sort of done. I mean, we wanted to connect our kettle, we wanted to connect our power meter to the internet, so let's just use an MQTT client and deploy the solution. I mean, it's not that hard to take values from your power meter, your thermostat, etc., do a couple lines of Paho code and send the data to the cloud. Turns out that, as I said earlier, you want to actually manage your solutions on the field, right? And why would you want to do that? Well, because when it comes to IoT, you will probably deal with several network bearers, like your solution, your power meter might have a cellular modem in it, but when it's in a house and the house has a Wi-Fi connection and a Wi-Fi network, then maybe by default, the meter wants to use Wi-Fi and fall back to cellular only in case of an emergency. So managing all these network aspects, managing the fact that maybe sometimes the network is actually going to be completely down and you still want your apps to behave sort of normally or as normally as possible. You want to manage the applications on the field, like when you want to deploy an upgrade to your thermostat application, you want to be able to do that remotely over the air. You want all your apps to be sort of sandboxed and stuff like that. You want to have hardware abstraction. So at some point, you're going to need to be using more than just a Paho or a Californium client. You want to have a complete framework, and the framework is probably going to be something you run on some sort of gateway, the gateway being sort of the home for all your applications and the orchestrator of all your different network interfaces and stuff like that. So typical gateway as a maker, I would say, would be Raspberry Pi or BeagleBone, Intel Edison, whatever. What the actual IoT players do is use more ruggedized stuff, but that's essentially the same sort of hardware. It's quite powerful, actually. We wouldn't call it an embedded device. It's probably mains powered, and it's ruggedized, right? It needs to work when the environment is humid and stuff like that. So at Eclipse, in terms of helping you to build your gateway, we have a framework called Eclipse Kura. It's been around for a while, and it's getting lots and lots of adoption. It's based on Java. It doesn't mean that your apps need to be Java, but well, the framework itself is developed in Java and OSGi, and it provides you with all the features to manage your IoT gateway. And we're going to see what exactly that is. If you are the kind of person who likes to play with Raspberry Pis and that kind of stuff, please do give it a try. It's super easy to install. You have a Debian package for Raspberry Pi, BeagleBone, Intel Galileo, so literally 5 lines to install it, well, maybe 6. Yeah, what do you get when you install Kura? You essentially get a framework, a daemon, call it however you'd like, that helps you manage the network and provides you with a nice abstraction of your firewall rules, your PPP connection for your cellular modem, provides you with a nice application container for your OSGi/Java apps, and provides you with also the abstraction of the communication between the gateway and the cloud. Since Kura is going to be your application container, you want to have Kura as the single point of actual communication between the edge of the network and the cloud, so as the apps don't really need to manage all the complexity of detecting when the network is down and possibly caching some data locally and flushing the data later on. So that's the kind of stuff Kura is taking care of for you. So when you install Kura on your device, it actually comes with a nice UI. similar to some extent to what you would find on your DSL gateway or on your OpenWRT router. It's a complete interface for managing the device. So we're going to actually probably see that live in a demo later on, but managing the status of the device, like what's my serial number, what's my GPS position, should I be connected to a GPS, what are the applications / OSGi bundles that are deployed, what's my network settings, like if I need to establish a 3G connection, I could configure the connection right from here, don't have to deal with all the weird and complex Linux config files, configure my firewall, opening some ports so as my applications can be reached, kind of stuff. Deploying actual applications. You can deploy new bundles, new software packages to the gateway pretty easily. Whoops. Deploying those applications either from the web UI or from remote APIs, right? Managing the settings of the gateway. Should something go wrong, I totally screw up my configuration, I can roll back to a previous snapshot. And manage all my applications, all the applications running on the gateway, like my greenhouse monitoring application and whatnot. If they expose settings, then I can easily change and tweak those settings right from the web UI. So as an application developer, you're probably going to use the Kura API to have not only access, of course, to the Java underlying APIs, but also you have the nice abstraction of the communication with the cloud. As I said earlier, you have this data service, this cloud service. If you want to cipher your messages, you have one nice simple abstraction to do just that, accessing the GPS, same. So that's pretty neat and pretty easy to deploy your applications in Kura. So that's for Kura. So hopefully in a few minutes in the demo, you will actually see how we took Kura, deployed our own app in Kura, used MQTT to push some data to an MQTT server, and then next step will be to actually make sense of the data. So by visualize, I mean consume the data in terms of actually visualizing it, or possibly also consolidating the data, since if I'm talking about millions of devices sending temperature, then maybe I want to do some consolidation and machine learning to actually detect some patterns in my things, and also just simply consolidate the data so as it's easy to process, right? So, well, in terms of consuming the data, if you're really just like interested in visualizing, seeing, watching, looking at your data, well, there's several solutions. Assuming you're using MQTT and you want to consume your MQTT data, you have plenty of options. Like if you're a JavaFX kind of guy, just take Paho and use JavaFX charts to build very nice and live data visualization. If you're an Android kind of guy or an iOS, for what it's worth, just use Paho for Java or Paho for Objective-C, and you can consume quite easily the data in your app. But what I also quite like is that MQTT allows you to consume your data right in your browser without needing any extra backend whatsoever. You can directly have your JavaScript code connect to the MQTT broker over WebSockets. So that's actually quite convenient in that, again, you don't really need to have an additional backend that would maybe take the data from the MQTT broker, store that in your MongoDB database, and then you use Express to export yet another API, et cetera, et cetera. And then you need also to address the push notifications, do long polling, whatever. With WebSockets, it's actually quite nice, and the API is very similar, if not identical, to the one we've seen earlier with Java. Just a couple lines of JavaScript code to establish your connection, and what's left is for you to do some code and manipulate your DOM, do some jQuery stuff in this callback, so as you actually use the data. And let's now see actually how it looks, and let's see the actual end-to-end demo. So I have this Raspberry Pi over here, and for the last couple of months, I've been working on making my demo completely sort of independent of internet access. So this box is actually running Kura. So this is the gateway, but this is also its own MQTT broker. So I don't need internet whatsoever. This is, of course, not what you would do in the real life, but for demo purposes, that's quite convenient, right? So this box is running Kura, and as I said earlier, Kura brings you a nice web UI, which hopefully will show up just here. All right, so that's exactly what you show in this, what you've seen in the screenshots earlier. What's the status of my box? Well, very cool. It's connected. It's connected to a specific broker, which is, again, as I said, a local broker. Should I have a GPS, it would show in there. And my Kura box is running an application for me. So this application is something that I've been building in Eclipse beforehand. It's a Java, a set of Java and OSGi bundles that are developed against the Kura APIs. If we have a couple minutes left at the end, I will actually show you some lines of code. But very, very easy to use the Kura APIs. Package the app in the form of a zip file. Basically, you deploy the app on your gateway, and then it starts doing its stuff, including possibly exposing some settings for you as an application manager, I would say, or an application operator to tweak. So this is some of the settings on my app. And so what's the app doing? It's actually talking to the sensors I have attached to my Raspberry Pi, namely a temperature and humidity sensor, a motion sensor, and an LED. So a couple lines of Java code using the Kura APIs to take those data, those sensor data, and send it to the MQTT broker. And once the data is in the MQTT broker, it's pretty easy to use Paho over WebSockets, plus, in my case, Angular.js to create a very simple data visualization UI. And in this case, that would be visualizing my temperature. So let's put the finger on the temperature sensor, and then, of course, the temperature goes up. Then the LED that you might not see unless you sit very much at the front. And when it blinks red, it's actually when it detects some motion. So if I just try to not move, yeah, not going to happen. Okay, now if I move, okay, so that's pretty easy to consume the data, right? Just like my Kura app, my Angular app is literally just a few lines of code, and I'm visualizing the data. What would be interesting to do next is actually to also do some data analytics. So of course, in the context of this demo, I only have one sensor, one solution on the field, but I would probably have many of them later on once I start deploying many greenhouses or whatever this is supposed to be. So how about using Spark? I mean, this is definitely not an Eclipse project, but yet Spark has support for MQTT and in particular Spark streaming. So in case you're not familiar with Spark streaming, it's essentially a stream processing solution that provides Java, Python, and Scala bindings for you to consume data streams. Could be sockets, like raw sockets, could be stuff coming from Kafka, could be the Twitter fire hose, could be 0MQ, Flume, blah, 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 and MQTT. So you have built-in MQTT support in Spark, which provides you with a nice programming model to consume this data stream coming from your MQTT broker, timestamped to some extent data, since it comes like at regular intervals. And what you probably want to do is consolidate the data, so as if you have a million devices like this sending temperature every second, then maybe you want to do some consolidation to compute an average, to compute a standard deviation, maybe some machine learning with Spark MLlib to detect clusters, and maybe you will detect that some sensors seem to be off by 1 degree or seem to be typically behaving not as expected. So that's actually quite an interesting combination, MQTT plus Spark streaming. And I want to show you just that. How many minutes do I have left, please?
Like 7, 8.
Perfect. Thank you. I just didn't look when I started. So yes, Spark. Let's start my a local Spark cluster, right? So I do have Spark installed locally, and I want to start a Spark master as well as a Spark slave running on my machine. So it's going to take a little while. Once it's actually starting, then I should probably be able to see my Spark web UI, like the web UI of my Spark main node. And here, looking at all the declared slaves, there's one Spark slave with 4 cores available for whoever is interested in doing some Spark stuff. And so what do I want to do? I want to use the Spark streaming Python API. Could have used Scala, but the Python API makes it easier to test your things pretty easily. You don't really have to compile anything whatsoever, so that's pretty convenient. Well, I think they have a Scala shell as well, by the way. So what's happening in my app, right? It's very simple. What I want to do is use the Spark API to connect to my MQTT broker. So so Spark is running on my laptop. MQTT, the broker is running on this guy, the Raspberry Pi, with this IP address. So that's how I reach my MQTT broker. That's how I subscribe to the data, the topics I'm interested in. My application is sending temperature values and motion detection values. I'm only interested in the temperature, create the stream, and then I want to do some MapReduce stuff to actually consolidate my temperature information. And I want to leverage the Spark streaming APIs to easily have a sliding window of, in my case, 15 seconds. What I want to do is sort of have a trend of what's the temperature of my devices, or my device in this case, on the last 15 seconds. So what do I want to do? I have this MQTT stream that is giving me all the information regarding temperature. So I want to make sure that the temperature is indeed representing a number. For some reason, there could be NaN values and stuff like that. Then I want to do some rounding because, well, I want to sort of start aggregating the values and do some rounding, and then very simple API to do to reduce my data set. So I want to categorize and to count essentially how many occurrences of 23 degrees, how many occurrences on 23.5, etc., etc. I want to sort the temperature also. And then what I will want to do is display it. I could also decide to dump it in my HDFS cluster, dump it on a local file, display it, pump it into a data visualization thingy. But in my case, I just want to display it. So I want to have some sort of a command line histogram, which is exactly what we're going to see now. So let's tell our Spark cluster that we actually want to run our little Python script. So what's going to happen is that we're going to enqueue this Python job into the main node, and then since we have a slave available with 4 cores available, it's going to start doing its job, right? If I go back here, you should see that, yes, there is actually a running application on my Spark cluster, and it's actually doing stuff. And what stuff is it doing? Well, it's displaying the consolidation over the last 15 seconds. So if I start warming my sensor, I sort of see a trend. So that's sort of a vertical histogram, right, of where the current temperature seems to be going, right? So I've been warming the sensor for the last couple seconds. So we're now sort of centered around 29 degrees. And again, now over the last 15 seconds, we seem to be rather centered around 28 degrees. If I were to have 1,000 more clients posting data on the same on a topic matching this pattern, then I would actually be consolidating all this data in just literally 4, 3, 2, however you format the code, lines of code, and that's a very nice programming model, and it's actually quite interesting to use Spark for this. So that's pretty much what I had in terms of data visualization. As I said to some people yesterday, we now have so many projects at Eclipse IoT that it's actually difficult to make a 40 or minutes or a 1 hour presentation where you cover them all. So the slides will be online. I want to make sure that you guys check out the other projects that if you're interested mainly in industrial IoT, industrial automation sort of stuff, we have things like Eclipse Kura, Rise V2G, which might be interesting to you guys. If you want to do device management, like we mentioned yesterday with Lightweight M2M and SIM card management and device provisioning, etc. Lightweight M2M is a great standard. Eclipse has 2 reference implementations of Lightweight M2M in Java and in C, called Leshan and Wakama, so check that out as well. Things around secure discovery by leveraging the DNS infrastructure, that's great stuff. Please come and talk to me after the session if you're interested in learning more. That's a very interesting project coming at Eclipse. Home automation, you guys may know about OpenHAB, OpenHAB. That's a great framework for building a home automation solution and like coordinating all your ZigBee devices, etc., etc. So check that out as well. And that's what I had for you today. Again, Kura is pretty cool, but that's not the only thing we have. But if you're interested in Kura, go check it out, eclipse.org/Kura. The demo, very simple, greenhouse-like sort of demo with the temperature sensor, a light that you can control. There's a tutorial for that you can check out online, and you will have all the instructions to replicate it yourself. And again, yes, just check out Eclipse IoT in general. Even if you hate Eclipse as an IDE, we have nothing to do with the Eclipse IDE. I don't think I even showed you Eclipse. I even used Sublime, right? So that's what I had for you. I hope we have a couple minutes for questions. Make sure to, yes, come on our forums, mailing lists. If you don't find information on the forums, just use me as an entry point. I'm sort of the so-called evangelist, so I should be able to help you make your way through the IoT jungle. Hopefully, ping me on Twitter, email, whatever. And that's it. Thank you.